last operation, which is unique to functions. So we can add, subtract, multiply, divide functions, just like we can add, subtract, multiply, divide numbers. We do arithmetic. But a process that is unique to functions because of how they behave is the composition. But we like the composition function. This is when I could take a function and input it into another function. I'm composing two functions. And so g of f of x, which is the easiest way to actually recognize this when we actually write it in the other form, it's where we're literally taking function f and plugging it into function g. And so we're combining, and then it's not a multiplication. It's a combining my two functions. And again, it's read f of g of x. Alright, the composition of two functions. The domain of, or sorry, the f of g of f of x. The domain of g of f is all of the x values in the domain of x, domain of f, such that, so first of all we have to check f of x. Alright, what's the domain of the input function? Alright, we have to know what the domain of the input function, and then the domain of the resulting function, of the final function. Those are the two checks. It's kind of like the division. Remember the division, we had to check both of my originals and then the resulting function. Well, this one, we only have to check one of the originals. We have to check the f of x, let's say the input, what I'm plugging in. What's its domain? Is it restricting me at all? And then the final resulting matrix, how does it restrict me? So there's two checks. The domain of the input function, what's going inside, f of x, and then the domain of the original, or whatever comes out. Right? The combination of the two functions. What domain do they give me? Right, so we're going to do an example. Here we've got f is a quadratic, x squared plus 3x plus 2. G is the rational function, 1 divided by x. All right, we're going to find f of g of 2 and g of f of 2, and how do they compare? And then we're going to find the two functions. And so the first one, we're actually going to find, what we're going to do is, so A, we're going to evaluate f of g of 2, which again, remember, writing it in the other form is a little easier to understand. And then we'll do the other one, g of f of 2. All right, so what we're going to do first is we're going to find g of 2. All right, g of 2 first, so g of 2 is 1 over 2, all right, and then plug that in. So then it's f of g of 2, which is f of 1/2. 1/2 goes into my f's function. And then we simplify and we get comes out 3.75 is f of g of 2. Alright, now the other one, g of f of 2, which again is the flip. G is the outside, f of 2 is my inside. So the first thing I have to find, I'm going to kind of do my scratch work over here to the side, kind of like I did this, f of 2. So f of 2, I have to plug it into that quadratic, so I've got to get my 2 squared plus 3 times 2 plus 2. And so this comes out 4 plus 6 plus 2. And so I get 12. Alright, f of 2 is 12. So that's what we're going to plug in. F of 2 is 12. And then find g of 12. Well, g is just 1 over the x value, 12. And so g of f of 2 is 1 over 12. And so we do get different answers. They're not the same. Right? If I write the fraction 3.75, right, that's the fraction 15 over 4 is different than the fraction 1 over 2. And so they're different. It matters which direction I plug in my functions. One direction gave me a bigger number than the other direction. Alright, I can give myself enough room to work, so I'm going to kind of give myself a little more room. So my next one is actually finding them and simplifying and finding my domains. Alright, so part B is finding f of g of x in general, which again I think is easier to write it in this form. And so I'm going to take g of x and plug it in f. And so I'm going to literally take my g of x, which is 1 over x, and plug it into my f of x. And so I don't have f of x listed here, so I might erase this and list them up above. Alright, so remember, g of x was 1 over x. F of x was the quadratic x squared plus 3x plus 2. And so what we're going to do is, well, I'm going to take g, actually maybe I'm going to write it out the other way. I'm going to take g of x and plug it into f. And so I'm literally taking the function g of x and plugging it in for the input. Well, the input's the x part, so it's going to be g of x squared plus 3 times g of x plus 2. Well, remember, g of x is 1 over x, and so that's what you're going to do. You're going to take 1 over x and square it. You're going to take 3 and multiply it by 1 over x, and then you're going to add 2. And so if we simplify, it's 1 over x squared, 3 over x plus 2. So there is f of g of x. Right, which we're going to find the domains of that in a little bit. We'll do that in the next part. All right, then the second part is we'll flip it around. F of g of x, the other way around, which g is my outside, f is my inside. So again, reminding you what they were. And so this is when we take g, which is 1 over x, and plug my function f in, which would be 1 over f of x. Right? And so f of x, if you remember, is the x squared plus 3x plus 2. And so I'm just going to plug it in and get 1 over that x squared plus 3x plus 2. And so 1 over x squared plus 3x plus 2 is the g of f of x, the new and they are, when you combine them this way, you do get completely new functions. And the last part of this problem is the domain. So remember, the domain has two checks. What's the domain of what I'm plugging in? And then what's the domain of my resulting equation? All right, and so for the first one, f of g of x, well, I'm plugging in g of x. And so the domain of g of x, I'm going to write the domains up here. The domain of g of x is everything but everything but 0, right? I can't divide by 0, so every x such that x cannot be 0. F of x can be anything, it's all reals. Alright, so keeping that in mind when I find my answers. And so for part B, f of g of x's domain, well, the input value I'm plugging in, I can't get 0. Well, as it turns out, that's the same thing for the output value. Right, I can't get 0 in this function that we got the result because I've got x squared, which will give me division by 0. And so it's the same domain. This also has a domain of every x such that x cannot be 0. Alright, same thing. The second one, my input value is f of x, right? So f of x is anything I want it to be, so I don't have to worry about the input, it's all reals. But I have to check the resulting matrix. So the resulting matrix was 1 divided by what I inputted. And so in this case, I do get division by 0. And so I have to figure out, well, are there any x values where that quadratic will give me, so I have to find the zeros of that. And so this one actually does factor nicely. Right? Those are the ones I have to throw out. And so it factors into x plus 2, x minus 1, or x plus 1, right? And so negative 2 and negative 1 are my zeros, and so those are what I have to throw away. And so the domain of g of f of x is every x value such that x cannot be negative 2 or negative 1. Everything else is fine though. Alright, so the last thing we're going to do is we're going to look at the graph again of this new case. So the same graph we had before, but now I'm going to add questions with compositions and then working backwards. So we're just going to go ahead and finish it here. So this is the graph I had earlier of function f and function g, which again, I'm assuming function f is a line, function g is some type of square root function. And so the first one is find f of g of 1. And so the first thing we do is, well, we find g of 1. Alright, g of 1 is 1, right? G of 1 is 1. And so we replace g of 1 with 1 and find f of 1, which just a coincidence that g of 1 was 1 in this case. And so f of 1 comes out 3. Alright, the next one was f of g of 0. So f of, set it backwards, g of f of 0, which again, I think it's you have to recognize this form, but I actually think it's easier to always write it in the other form. So it's g of f of 0, right? F of 0 is my input. And so first thing we do, find f of 0. F of 0 is 1. Right? F of 0 is there. And so then it's g of 1, which we know g of 1 is 1. Right, so that's a graphical example. Now, the last thing, which is actually very important, is working backwards to recognize, because if you go on to 135, which is applied calculus, you have to take a derivative of compositions, and how you do it is you have to recognize the inside, the outside function. So what created the composition? And so we want to work backwards to find f and g such that f of g of x is what we're looking for. It's f of g of x. And so g of x is the inside, f of x is the outside. And so looking at h of x, what's the innermost function? Well, the innermost function in this case is the 2x minus 1. And so g of x is 2x minus 1, which that's inside that cube root. So f of x was the cube root of x. And those are the two functions. If you go back and you plug them into each other, you should get the original expression, right? If I take g of x and plug it into f of x, I get back to this h of x, and I do. The same thing for this one. So what's inside of another function? Well, the x plus 7 is inside the 1 over x to the 5th. And so g of x is x plus 7. F of x, or if I replace that with x, so I get 1 over x to the 5th. And some reason this second one is the harder of the two for students. They get the first case pretty easy, this one. But for some reason the second one is a little harder for students. And I don't know why, for whatever reason it is. But always check your answers. If I went and took and found f of g of x, right, using these two functions, I should get back to the original. And I do. I take f, plug in x plus 7. F was 1 over x to the 5th. I get 1 over x plus 7 to the 5th, and it checks. Alright, so these are my inside and my outside functions. Alright, we will stop there. So that is, again, just reminding you of some algebra with functions, and then the special case, which is the composition, was the harder of them, which is unique to functions. Alright, we will stop